Hi all dear physios and budding physios, welcome to Physio Brainery. In this video, I am going to briefly explain about electromagnetic spectrum and about different electromagnetic waves which forms this electromagnetic spectrum. Coming to the introduction, the electromagnetic spectrum is a term used by scientists to describe the entire range of light that exists. Electromagnetic spectrum is the range of all possible frequencies of the electromagnetic radiation. Electromagnetic radiation extends over a wide range of energies or wavelengths or frequencies. So the ranges starting from your radio waves to your gamma rays. Most of the light in this universe is in fact is invisible to us. Light is a wave of alternating electric and magnetic fields, that is electromagnetic radiation. Electromagnetic energy travels in waves and spans a broad spectrum from very long radio waves to very short gamma rays. The human eye can only detect only a small portion of this spectrum called as visible light, that is VIBGYOR. A radio detects a different portion of the spectrum and an X-ray machine uses yet another portion. NASA's scientific instruments use the full range of electromagnetic spectrum to study the Earth, solar system and the universe beyond. When you tune your radio, watching your TV, send a text message or make some popcorn in a microwave oven, you are using electromagnetic energy. So electromagnetic energy are used in different forms in our day-to-day life. You depend on this energy every hour of every day. Without it, the world you know could not exist. Electromagnetic waves form a continuous series in order of changing wavelength, frequency, and energy. This series is called as electromagnetic spectrum. So electromagnetic spectrum is nothing but the continuous series of electromagnetic waves in different wavelength, frequency, and energy. So this is the graphical representation representing the frequency and wavelength of different waves that includes your gamma rays, X-rays, ultraviolet rays, visible rays, infrared rays, microwaves, radio waves, and your long waves. So until radio waves. So what are the different types of electromagnetic radiations? So the starting is radio waves. So radio waves, as you know, they are having a lower frequency. You can see this is the frequency. So they are having a lower frequency, but they are having a longer wavelength. Because of this longer wavelength and lower frequency, they will be having a lower energy. So these radio waves are used to broadcast radio and television. Next is your microwaves. They are used in cooking, radar, telephone, and other signals. Next waves is your infrared waves or infrared rays. They transmit heat from sun, fires, and the radiators. Next is your visible light, that is your VIBGYOR, different colors that makes things able to be seen. And next is your ultraviolet rays. This is absorbed by the skin, used in fluorescent tubes. Next is X-rays. So they are used to view inside of the bodies and the objects. And next is your gamma rays. They are used in medicine for killing cancer cells. So this is another graphical representation of the difference between the wavelength, frequency, and energy of starting from your gamma rays to your radio waves. In the gamma rays, they are having a shorter wavelength, higher frequency, and higher energy. So you can see here higher frequency, but shorter wavelength. So because of this, they are having a higher energy. And while going from gamma rays towards the radio waves, you can see here there is a change in the frequency. The frequency is getting lesser, and the wavelength is getting higher or increased. And because of this lower frequency, they will be having a lower energy. So gamma rays will be having higher energy and radio waves will be having lower energy. So from gamma rays moving towards the radio waves, the energy will be getting reduced and the frequency will be getting reduced, but the wavelength will be getting increased from gamma rays moving towards your radio waves. So this is the difference between different waveforms in the electromagnetic spectrum. So this is another graphical representation of different waveforms. So this is the wavelength. So wavelength radio waves will be having 100 meters of wavelength, and while moving towards from radio waves towards the gamma rays, they will be having lesser or lower wavelength. So the gamma rays having a lower wavelength of 0.01 nanometer. So coming to the radio waves are having low energy because of the lower frequency, but they are having a longer wavelength. So this includes FM, AM, radar, and TV waves. The wavelengths were of 10.-1 meter and longer. So since I already told, there are lower frequency. And they're used in many devices such as remote control items, cell phones, wireless devices, etc. So the radio waves has been used in different devices such as your remote control items, cell phones, wireless devices, etc. Next is your microwaves. So microwaves are longer than the radio waves but shorter than the infrared or visible light. The wavelength ranging between 1 into 10 raised to minus 4 meter to 1 into 10 raised to minus 1 meter. And they are used for communication, medicine, and consumer use. Microwave ovens, as the names denotes, microwaves denotes microwave ovens. They are used in the producing the microwave ovens. So next waveform is your infrared waves. So they are invisible electromagnetic waves that are detected as heat. They can be detected with special devices such as night goggles. They are used in heat lamps. Higher energy than microwaves, but lower energy than the visible light. So infrared waves or infrared rays are having higher energy than the microwaves, but lower energy comparing to your visible light. And visible light, the portion of the electromagnetic spectrum that human eyes can detect is your visible light. So you already know regarding the rainbow, that is your VIBGYOR: red, orange, yellow, green, blue, indigo, and violet. So this forms the visible light. So the red color has having the lowest frequency and the violet is having the higher frequency in the visible light or visible spectrum. So electromagnetic radiation in the range of 0.4 micrometer to 0.7 micrometer. In other words, it is known as 400 nanometer to 700 nanometer is known as the visible region or visible spectrum. This is the wavelength of the visible light. The white light contains a mix of all wavelengths in the visible region. So the wavelength of visible radiation or visible spectrum is in between the 400 nanometer to 700 nanometer, in which the red is having the lower frequency and the violet is having the higher frequency. So the visible portion of the spectrum, the violet is 400 nanometer to 446 nanometer, and the blue is having 446 nanometer to 500 nanometer. Green is having 500 nanometer to 578 nanometer. The range of yellow is in between 578 nanometer to 592 nanometer, and the range of orange in between 592 nanometer and 620 nanometer, and the red between 620 nanometer to 700 nanometer. Among these, blue, green, and red are the primary colors. And there was an experiment done by Isaac Newton in 1666. He passed the white light, so white light in a glass prism, and he finally concluded that when passing the white light through the glass prism, it forms or it splits into different colors. That is 7 colors. That is your VIBGYOR: red, orange, yellow, green, blue, and violet. So this is the splitting of white light into different colors. That is VIBGYOR. This was an experiment done by Isaac Newton in 1666. And next waveform is your ultraviolet waves. So they are higher. They are having a higher energy than the normal light waves, and they can cause skin cancer and blindness in humans. They are used in tanning beds and sterilizing equipment. So next waveform is your X-rays. X-rays is having higher energy waves. They are used in medicine, industry, and astronomy. And X-rays, too much of exposure to X-rays can cause cancer. And the last but not the least, that is your gamma rays. Gamma rays is having the highest form of energy because of the higher frequency and the shorter wavelength, and they are blocked from Earth's surface by the atmosphere. So they are used in medical treatment for curing the cancer. So coming to the uses, most parts of the electromagnetic spectrum are used in science for spectroscopic and other probing interactions as ways to study and characterize matter. In addition, radiation from various parts of the spectrum has found many other uses for communications and manufacturing. Thank you for watching this video. Please do subscribe this channel and share this video to your physio friends and community. Thank you.